When facility information is accurate, complete, and timely, it can optimize design decisions, increase constructed value, and support effective management of the facility. Hi, this is Kevin Connolly, President of Connolly Architects and founder of Capital Facility Industry Information Works, or CFI InfoWorks for short. Thank you for taking the time out of your busy schedule today to learn about these important trends and ideas. When you think of information exchange in the capital facility industry, you may think of things like architect's blueprints sent to a contractor for pricing, or a contractor's operations and maintenance binder handed over to the owner at closeout. These kinds of information exchanges have been going on for hundreds of years. Recently, developments of the PDF and other document formats have allowed us to exchange digital copies of ARC documents. But these kinds of information exchanges don't ensure accuracy of the information. They're not complete, nor are they timely. But mostly, they're not the kinds of information exchanges that are going to move our industry forward. In this part one of our three-part series, you will learn the differences between digital documents and digital data, and see some examples of how digital data exchanges are now benefiting the capital facilities industry. In part two, you'll gain an understanding of the challenges involved in information exchange. And in part three, we'll show you strategies and tasks to begin integrating digital data exchanges into your development and management processes. Let's get started. We've been exchanging information pretty much the same way since the Renaissance, with paper documents. Recently, as I said, we've been exchanging digital copies of these documents and using document registries and other storage and retrieval systems to make our processes a little easier. But we are still exchanging only a snapshot of our work effort. Other than viewing it, our computers can do nothing else with it. That is to say, the computable data is lost, or at best, it's stored in an inaccessible location to those who may need it. And by the way, as soon as it's stored, the so-called process of data rot begins. What needs to be exchanged is the information about what is on that PDF. In other words, instead of the architectural floor plan, information about the floor plan is exchanged, like materials, quantities, room sizes, shapes. Instead of a leasing manager's space utilization report, for example, being exchanged, information that's on that report should be exchanged, like suite and room square footages, rent factors, tenant histories. And all the information needs to be exchanged in an interoperable digital format so that other computers can understand and use the data. So when a leasing manager wants to see, say, available suites in building 29B under 2,000 square feet facing east and wants the computable rent factor as of that moment, it's a button push. When detailed information is in digital format, exchangeable with other systems, efficiencies grow exponentially. But the real potential is in discovering the data without any pre-existing knowledge that it exists, to be able to find new relationships between information, to be able to study the present situation as the leasing manager did, and more importantly, the future ones. What social, economic, or political effect could a particular virtual decision have on the future? This is what we mean when we say information exchange. My friend and software support partner, Kimona Numa, reminds us that data exchanges are all around us. He likes to show this Expedia analogy where he logs on, types a destination, and then Expedia exchanges digital data in real time with hundreds of airlines, hotels, and car rental databases. Then in a few seconds provides choices relevant to Kimona's specific criteria. And that's how facility information should be linked, to have the ability to retrieve accurate, complete, and real-time information about current or future conditions based on what you know or don't know but need at this moment. Again, it's all about the data and all the wonderful relationships that can be made between it. As I have said, when facility information is truly accurate, complete, and timely, it can optimize design decisions, increase the constructed value, and support effective management of the facility. Let's look at some examples of how information exchanges are benefiting each of these three desired outcomes. When an architect's design solution starts to take shape, one of the key factors is energy use. Energy-saving design techniques like building orientation and shape, materials, glass areas, sun control, natural ventilation, and others are studied. As alternate concepts are developed, specific data related to each of the schemes is exchanged with an energy program. The program instantly reports the relative amount of energy that scheme would use over a 1 year period. And of course, you don't know if you've optimized a decision until you know what the costs are. So along with an energy analysis, a cost analysis is done. The software writes out a quantity list. That's what computers like to do. They like to count stuff. This is then exchanged with a cost database to produce the relative costs of those energy decisions. The iterative process continues, and the design refines until the right benefits for the right costs are reached. Another really interesting example of design is design solution checking. A designer can exchange specific design data with checking software. This software has rule sets, as they're called, that will validate things like, are all spaces of correct size, function, and location based on the owner's requirements? Or do the rooms have the required adjacencies and circulation paths to them? In the near future, this same software will be checking the design for compliance with building codes. Well, let's move on to our next example. The construction industry is one of our capital facility industry's fastest adopters of these new technologies, and rightly so. They're saving their customers thousands, if not millions of dollars. Construction errors, time delays, material wastes are declining thanks to virtual construction. Designers first are exchanging their information with contractors' databases and software. This immediately saves time and errors by not having to recreate that information. The contractor then dissects that design into its constructible parts, adding detailed construction and process data. The entire facility is virtually built in the computer, catching many of the errors that might have taken place in the field. Some of this data can be exchanged with digitally controlled fabrication machines, creating the component directly from the database, again saving time and reducing errors by not having to re-enter that data. Then it's off to the construction site, where the actual construction is basically a duplicate of the virtual construction. Now, probably the most valuable of all information exchanges are the ones that occur between all team members and the facility manager. As implied, this would need to be a series of exchanges that occur as information is created in order to get all the detail the facility manager needs. That's exactly the idea behind the construction operator's building information exchange. COBie is a data format and process developed by NASA and the Army Corps of Engineers. It provides a means to capture specific information about a facility as it's created or becomes known. The process literally starts when a building project is contemplated. Then site, building areas, and space data are added as soon as they are confirmed. The designers, constructors, and commissioning agents all continue to exchange their specific information with the COBie database the moment it is known. Data can be entered manually, like this example shows. This is basically an Excel spreadsheet. However, many design, construction, facility management software packages are now COBie compliant. Let me show you what this means. We will use one tiny piece of a facility for an example. Early data about a door is entered into the design file by the architect. Its representation can be alphanumeric, 2D, or 3D. The designer exports the data from the COBie compliant software in COBie format, which is then exchanged with the contractor's database. The contractor adds installed hardware and keying information, for example, to the database, then exports the data in COBie format and exchanges it with the facility manager's maintenance and management systems. Finally, the facility manager uses that door information and its associated data to populate a work order. The concept is to add information once, then exchange it and build upon it over the course of a project. If followed, the process ensures the facility manager will get all the information he or she needs to effectively manage the facility. Well, these are just a few examples of the hundreds of exchanges now occurring across the capital facility industry, and a foretaste of the thousands yet to occur. And these are the kind of information exchanges that CFI InfoWorks helps teams make to ensure owners get the most value now and in the next 50 years. I hope you've gained an appreciation for the potential that digital data has. And if you're like me, your mind is probably racing to all sorts of possibilities. But there's more to this than just going out and buying software. There are significant information exchange issues lying ahead. What they are and how you might begin to understand them is the topic of the next part of this series. Thank you again for your time today.